All right, friends, welcome to the video on 6.5. This is Math 8, by the way. So we're in Math 8, 6.5, and we're analyzing and sketching graphs. So what we want to do is be able to look at a graph and understand what it means. So think about these graphs for a second, and we want to match them. So what I'm going to do is I'm going to give us a little bit more space to look here, and we've got a couple of different options. So here are some options. 1, 2, right? And there's some more options down here, 3 and 4, some more options. So the question is, which option goes to which graph? So I'm just going to read through them. One says, you gradually increase your speed, then ride at a constant speed along a bike path, then you slow down until you reach your friend's house. So I look at these and I say, which one even has a constant speed? Like I know that A doesn't even have a constant speed, because I never see the speed flat. You know what I mean? Like the speed is never like, it's either going up or going down. Yes?
C, D, actually all of them besides A.
So B, C, and D all have constant speed, but B starts out at a constant speed, right? Madison?
I'm saying C.
C. So I would agree with that. So I would say C is a pretty fair reason. So C is the answer to number 1, and we can scratch it off of our list because we see that we are increasing our speed. So let me just do this. You gradually increase your speed is green. And I'm going to write you gradually increase your speed. Then you ride at a constant speed. Okay, and I'm going to show you riding at a constant speed is here. And then after that, you slow down, right? So your speed goes down. That's that graph. Okay? And hopefully the colors help you to see it a little bit better. I'm going to erase those so that I can reuse them. And we're going to look at the next statement. You gradually increase your speed, then go down a hill, then quickly come to a stop at an intersection. You gradually increase your speed, then go down a hill, then you quickly come to a stop at an intersection. This is a tough one. What are our thoughts on this one? A. Okay, so A is an option, so why? Why A?
Because it gradually increases.
Right.
And then
Gradually
goes
increasing.
faster down the hill.
And goes faster down the hill. That makes a lot of sense. Gradually increase your speed. So we're gradually increasing our speed. You're saying it goes faster down the hill. Oops, sorry. This is the wrong spot to be. See if I can grab that little line. I don't know if I can do it. Oh, there we go. Okay. Let's see how many smartboard skills I have now. Okay. You know this would happen, guys. Okay, good enough. You gradually increase your speed, then go down a hill. So I would say going down a hill, we're going to go faster or slower? Faster, yes?
But it's also, I'm saying A because it touches it back.
Good. So also we have that we quickly come to a stop, right? Come to a stop would be hitting the x-axis right here. Speed is equal to what? 0. So we quickly slow down and come to a stop on this graph. Does that make sense? So that's B for this one. And now we can go on to our next problem, right? Our next one. Does that make sense? Oh, sorry about that. Yep, I should have wrote A here. So this is A, like we kind of had said. And then on this, we want to gradually increase our speed, go to a store, buy some stuff, I guess, and then continue to ride and increase our speed. Yes, Madison, jump on.
Okay. I'm saying D. Because so you're increasing your speed and then like you're stopping at a store, so you're like stopping. Your speed is going to stop. So you're on the x-axis and then you're.
So you're saying like, okay, we're gradually increase our speed, then we stop at a sort. Did you say D?
Yeah.
Okay, I think that I agree with that. So let's just try to see why. Gradually increase our speed. So they kind of keep doing that, right? Oh, that makes sense because this is the only one that increases the speed anyways. Then we stop at a store. So when I see stop at a store, I automatically want to think about hitting the x-axis. So now I'm stopped at a store. I just chill at the store for a while, so I'm stopped there for a couple of minutes. So I'll say a couple of minutes, right? Does that make sense? And then I want to eventually continue to ride, gradually increasing my speed. So that would be D. Let's just read the last one. You ride at a constant speed, then go up a hill. So you're going to slow down going up the hill. And then on the top of the hill, you gradually increase your speed. Does it match with D? It does, right? Makes sense. So we're in pretty good shape here. These aren't too bad, but there are different situations of just speed and time, right? So let's just look at some other things that could go on here. So this one says sketch a graph that represents the situation. So I think you might be on the back now of your page. And if you wanted to give a little explanation of what's happening on the front, that wouldn't have been a terrible thing, but let's look at this one. We need to sketch it. So I'll sketch the first one, then I'll ask you to sketch the second one. A stopped subway train gains speed at a constant rate. So I'm going to write my graph, and I think I'm going to do speed here, right? And then I'm going to do time here. So it's a stopped train. So I'm just going to have the train being stopped on the x-axis, or the t-axis in this case, right? And I'll start a little bit over, not like maybe 1 second into this discussion. It gains speed at a constant rate. So we know that it's going to gain speed, so I'm going to pick up speed for a while, and I'm going to stop. Until it reaches its maximum speed, it travels at this speed for a while. So should I go up or down, or just stay the same? Stay the same, stay constant at this speed. So stays at this one for a while, so let's make it a while, okay? Then slows down until coming to a stop. Then slows down, coming to a stop. So it's got to slow down, and can I stop here? No. When do I have to go until I hit? Yes? I have to go until I get to an actual stop. This is the actual stop. To a stop. Right? So that's the graph. So I want you to draw a graph, and I'm going to give you what to label the graph, just in this situation. A television size increases, price increases, at an increasing rate. That's kind of crazy. So I'll make this price, and I'll make this the size of the television. So we know that a 65-inch screen TV is going to be more expensive than a 32-inch TV. So as the size increases, the price increases at an increasing rate. I want you to pay most attention to at an increasing rate. That can get a little weird. So pause the video and try this, just real quick. The first thing that you might find helpful as you're trying this is that when the price goes up, it's not going up at the same rate. It's not going to be a straight line, okay? Because as you get to a TV that like if you think about it, like TVs, the small TVs, if you get a TV that's double that size, it's not double that price. It kind of like continues to get more and more expensive. Do you know what I'm saying? So like a 60-inch TV to a 61, right? Or to a 65. A 60 to a 65 is maybe maybe a little bit more money. But a 65 to a 70, how much more is that? A lot more. And then what if you wanted to go from a 70 to a 75? Even more money than from a 60 to a 65, right? So what we need to understand is that this graph is going to be a curve. That's the big hint. It is going to have a curve to it. So pause the video and see what curve you think you're going to have for this graph. So remember to pause the video. I'm going to show you how to do this, but hopefully you've given it a try for now. So what I've got is the price is going up a little bit, and then the price is going to go up more and more. So I'll start with the price going up a little bit. Price is going up. Now it's going up more and more, right? And now it's going up more and more and more and more. This is what's going to happen. If you wanted a 200-inch TV, how much do you think that's going to cost?
A lot of money.
Yeah, you'll have to special order it. some like special TV crafter will have to make it. You could get a 200-inch TV. I'm sure you could get a 200-inch TV, but it's going to be so special that you're going to have to pay so much money. If you wanted a 300-inch TV, I'm sure they make them somewhere, right? But you're going to have to hire a team of people to do research on how to make a 300-inch TV and still power it off of a regular outlet. You want a 300-inch TV, you're going to spend so much money, it's ridiculous. So it goes up more and more as time goes on, yes?
Why couldn't it have been just a straight line going?
The increasing rate is the reason. Because what I'm saying to you, Lily, is that when you're looking at TVs that are like 30 to 40 inches, they're close in price. But when you're looking at TVs that are 40 to 50 inches, like a 40-inch TV and a 50-inch TV, they're not as close in price. And when you do, if you want to jump from a 50-inch TV to a 60-inch TV, they're way different in price because 60 is like kind of more cutting edge. You want to go from a 60 to a 70, which they do make, right? That's going to be way more in price. And if you want a special order on 100-inch TV, you're going to spend even more than that. So it goes up, it gets worse and worse and more expensive. Actually, we can think about how math can save us some money here. Because what we could do is we could realize when is a good time to buy the TV. Like, I know it just keeps on going up and up, but is it wise to buy a TV that's here? I mean, maybe that's a little excessive, wouldn't you say? So you kind of want to be somewhere in the sweet spot. You don't want to get the most expensive, brand new, biggest TV possible. If you just get one that's a little bit down from that, you'll save yourself probably quite a bit of money. Kind of interesting. So let's go on and do one more, and then we're going to mostly just need to practice this. So here's a graph. A fully charged battery loses its charge at a constant rate until there's no charge left. You plug it in and recharge it, then it loses its charge at a constant rate until it has no charge left. I would like you to try this one because it's a little bit simpler, and problem number 3 down there is going to be a little bit crazier. So why don't you pause the video and try this one. Fully charged battery. What would our things be? I guess it would be the charge and maybe the time. Would that make sense? So I would say charge and maybe time. Keep the current color screen. That sounds good. Okay. So here's the charge. And this is going to be time. And this is what I recommend you using to make this. Does that make sense to you? So try that out. Think about that. Pause the video. Give it a shot. Okay, so we want to wrap this video up. So I'm just going to show you what you should have had here. Your battery is losing its charge. So why don't we say, instead of a fully charged battery, why don't we say a phone battery? Okay. And you know your phone is fully charged, so it's here. And I'll put 100 for 100%. And I'm using my phone all day. Like, let's say I'm just using it the same amount. And it's just losing its battery, right? And now it gets down to, like, there. And do I charge it right away, or does it take a couple minutes? Well, I mean, what I'm saying is, like, do you always have a charger on you the second your phone dies? Yes. Oh, wow. That's very impressive. Usually, I don't carry the charger around with me, so I wait a couple of minutes with a dead phone. 0 battery. I don't know. I'm just trying to be a little bit more creative, right? Do you think it charges faster than it drains the battery? Yeah. If you talk on your phone the whole time, how long will that take, and how long does it take to charge? Does it charge faster, or does it die faster? Is this just us hating our phone companies, or is this because? Okay, let's say it's supposed to charge faster. It's supposed to charge in like 20 minutes, and then you can use it for like 4 hours. So it should charge up like that to 100%, a little steeper. And actually, let me make my graph a little more accurate, because I think it should be a little slower on the dying. I know that you don't feel that way all the time. It should slow down on the dying, stay dead for a little while, and then charge fast. That's what's supposed to happen. Okay? But we don't know. It doesn't have to be just like that, but you should have something along that line. We're going to wrap up the video here. Thanks for watching. I'll see you in the next video. Peace.